Hello, this is Jeffrey Fox again, back on the introduction to the Big Data Open Source Software and Projects course. This is the last part of the introduction. Remember, the introduction is divided into 3 lessons. This lesson describes some aspects of jobs and some general trends in the general computing big data area. And that's the start of this new section. And here's something I've already mentioned, effectively Moore's Law, which of course, has this remarkable statistic of going from $500 to 5 cents from 1990. I mean, 1990, we thought we had pretty good computers in those days, but obviously they're not as good as we have today. And this uniform exponential decrease is typical of the Moore's Law constant factor every year. Notice something which I already mentioned, that the two ways you can use this Moore's Law improvement. The old way it used to get used was to get better performance in a fixed size machine. For instance, a supercomputer used to always cost $30 million. At least the largest ones did. They now actually cost more, but in the past they cost $30 million. And so given Moore's Law, you could just pack more computers into each supercomputer and get more performance. However, now there's a different way of using it, because actually putting multi-core chips in PCs is not so helpful, because there's not so much parallelism on a typical PC job. So rather, you use this decreasing compute core size and to basically build smaller devices, namely at the lowest level, the Internet of Things, and somewhat above that, the smartphones. And so we're able to build very powerful small devices now, which you couldn't in the past. Here we see the same trend with storage, going down actually somewhat more. And this is why we can still store the 6 zettabytes of data that we introduced earlier stage. And at one stage, people actually thought storage would decrease a little less slowly than computing, but actually it's actually at least as fast, if not slightly faster, 38% annually. Here we see the third component, bandwidth of computing. Trivially, it doesn't look as though it's going down as much, just going down to $16, but the scale is different. It's only half the number of years, and so actually this is not so different. It's 27% opposed to 38% on the previous graph. It's still a nice continuing exponential decrease, which doesn't seem to be leveling off. The last graph of this type is a very well-known one from the National Institute of Health. At the top here, we have the purple graph, which is what we saw already. It's Moore's Law for computing, nice exponential decrease. And then we see superimposed on it the cost of sequencing a genome. And it is interesting that between 2001 and 2007, actually, that cost tracks computing quite well. But then whole new techniques, new ideas came along. And here we have a very large factor, possibly as much as 1,000 between computing and the cost of getting a genome. And this corresponds to Illumina, who've come up with a large machine that, if you use it in bulk fashion, can get you a human genome for $1,000 each. Notice that this has implications for analysis of bioinformatics data, namely the fact that the cost of producing the data has gone down so much more than the cost of computing, means that if you set up a biology project or bioinformatics or health project, computing pays a more important, the cost of the computing gets more larger just because of this factor of 1,000 here. We can get 1,000 times as much data as we used to in the past. Here's a rather different graph, which is just to point out that how the world is developing. Blue is the US, which wasn't so big in 1820. Now it's of these particular segments plotted, the largest at 19%, but is obviously being chased very aggressively by China, up at 16%. Notice China was 33% in 1820. It's always been an important world power. And the 9% here is Latin America. India is down here at 6%, obviously a big growth expected there. And Europe is not doing quite as well. It had a period when it was way larger than the US. They were sort of crossed at the Second World War here. Europe actually stayed ahead. But recently, since 1990, the US has kept above the European figures. But anyway, these are the players in this field. Here is an important trend. We've already stressed in the Gartner discussion the importance of mobile devices. And I've told you why Moore's law favors mobile devices, because we can't really use Moore's law very well in PCs because we don't really want to put 100 cores in a PC. Nobody's thought of a good use of them. So we're expecting mobile use compared to PC and laptop and use to increase. And that's currently it's now at around 25%, increasing from less than 1% in 2008. So that's a huge increase, which is expected to continue. Yes, there's expected continuing increase in the mobile fraction of internet traffic. This is sort of a vendor plot along the who are the big players. This is well known to all of you. We know Samsung is a big player. Apple is a big player. Both of those have gone down, largely because of the increase of this other category, which is a lot of in-country Chinese, Indian, and other Asian vendors. You have here the big China vendors, Huawei, Lenovo, Xiaomi, other European vendors. You have here Microsoft, which of course purchased Nokia. Motorola is hanging in there. And of course, BlackBerry is declining in importance and is actually going out of the hardware business, I believe. So there's lots of changes here. And we also know that actually the Samsung is largely Android and so on. In fact, Android dominates the operating systems used. This plot here shows you here's the global internet. Remember, there's 7 billion people in the world, so the global internet is not so far off its maximum it could be. And of those, the vast majority use clouds. So that just says cloud computing is a huge, important fraction of the world. This is a very specialized plot because it's only a cloud storage, which is a small part of cloud services. It's a pretty useful one. Many people like me use cloud storage. And here you have Box, which is actually what Indiana University uses. Dropbox, the best known of the early systems of this type. Here's Microsoft, Google, and Apple, which are all around sort of in the same ballpark, at least 4 here. There is no dominant vendor in this field. We can expect more competition and better service in this area as cloud storage becomes more and more important, because we're going to not be carrying around our disks with us as we do today. At least I do, mainly because I can't guarantee internet service everywhere. Like I cross the Atlantic and my internet service carefully switches off. So, and I go into sweet, beautiful areas, it switches off. So as internet service gets more broadly available, the need to have the disk with you will gradually disappear. The final set of slides of this thing are very important. They discuss what you're here for, the jobs. The first plot comes from Microsoft, and it represents the jobs in cloud computing, interpreted, I think, rather liberally. because obviously if you're using a cloud, then that's a job in cloud computing. It's down in total here from 2012 to 2015, goes from 7 to 14 million. And up here it's done by a country, with China having the largest opportunity. US is down there a factor of 4 below China. That reflects population, because the actual fraction here, the US is 7.7%, 0.7 of 1%, and China is 0.57 of 1%. And if you look at these country fractions, they're largely in that domain, with the peculiar exception of Poland, which is 0.16 of a percent, and maybe Russia. But of course, Russia is certainly a strongly growing internet force. So these fractions will certainly equilibrate, and I doubt it will see so much differences in the future.